Hello everyone. In today's lecture, let us discuss about the exceptions in ARM. In general, exceptions are conditions or system events that usually require remedial action or an update of system status by privileged software to ensure smooth functioning of the system. An exception is therefore any event that causes the currently executing program to be suspended. So exception is any event that causes the currently executing program to be suspended. Taking an exception causes a change in the state to execute code to handle that exception. How exceptions are being handled? See, this is the normal program flow. So this is instruction 1, instruction 2, instruction 3, and we'll be having thousands of lines in a normal program flow. If any exception occurs at a particular time instant, then that exception will be taken, and then exception handler will perform whatever the program or code it is having, the exception handler is having, it will execute the code, and then after completion it will return back to the normal program flow. This is how exceptions are handled. That is, whenever it sees an exception, it will take to the exception handler. The exception handler will be executing the exception, and then it will return back to its normal position. Different types of exceptions are there. Exceptions are used for many different reasons. One is emulating virtual devices, virtual management, memory management, handling software errors, handling hardware errors, debugging, performing calls to different privilege or security states, handling handling interrupts, handling across different execution states. So all these may lead to exceptions. Exception categories. It is classified into two types. One is synchronous exception and another one is asynchronous exception. Synchronous exception are exceptions that can be caused by or related to the instruction that is currently being executed. So an exception is suspending the current task and moving to a exception handler. Suppose if the exception handler has a code which is relevant to the main program, then we call it as a synchronous exception. So if the following are applied, then the exception is synchronous. If these conditions are satisfied, then we say that those exceptions are synchronous exceptions. One is which is generated as a result of direct or attempted execution of an instruction. Second is the address to return to once the exception has been handled has an architecturally defined relationship with the instruction that caused the exception. And the third one is exception is precise, meaning the register state presented on entry to the exception handler is consistent with every instruction before the offending instruction having been executed and none after it. Then we have invalid instructions and exceptions. Synchronous exceptions can be caused by attempting to execute an individual instruction. There are many reasons for invalid instructions, including instructions that are undefined, not allowed at the current exception levels. Then the architecture also allows a controlling entity such as an OS to set up traps to intercept operations at lower exception levels. Then memory access is another exception. Synchronous exceptions can also be caused by memory access. This could be a result of checks performed by the memory management unit or due to errors returned by the memory system. Then exception generating instructions. These are instructions that intentionally causes an exception to be generated and taken. These instructions are used to implement system call interfaces to allow these privileged software to request services from more privileged software. These are sometimes called system calls and are often used in software-based APIs. The ARM architecture includes exception generating instructions like SVC, which is supervisor call, HVC, which is hypervisor call, and SMC, which is secure monitor call. The purpose of this instruction is solely to generate an exception and enable the PE to move between exception levels. So, supervisor call instruction enables a user program at EL execute level 0 to request an OS service at EL1. Hypervisor call instruction available if the virtualization extension or implemented enables the OS to request hypervisor services at EL2. The secure monitor call instruction available if the security extensions are implemented enables the normal world to request secure world services. Then next is debug exceptions. So debug exceptions or synchronous exceptions that are routed to the exception level where debugger is hosted. There are different types of debugger exceptions: breakpoint instruction exception, breakpoint reception exception, watchpoint exception, vector catch exception, software step exception. Asynchronous exceptions. So, synchronous exceptions are if the exception handler has the same program which is relevant to the main program. So if it doesn't have, if the interrupt exception handler has some other program which is irrelevant to the main program, then we call it as obviously an asynchronous exception. In asynchronous exception, we have physical interrupts. Interrupts, those are generated in response to signal from outside the P. And then UART, the signal from Universal Asynchronous Receiver Transmitter interface to communicate with outside world. When the UART receives data, it needs a mechanism to be able to tell the processor that the new data has arrived and is ready to be processed. One mechanism that the UART could use is to generate an interrupt to signal to the processor. Next is system error is an exception type that is intended to be generated by the memory systems in response to unexpected events. So, typical examples of system errors are memory access which has passed all the memory management unit checks but then encounters an error on the memory bus. Similarly, parity error correction and detection. Then an abort triggered by write back of dirty data from the cache line to external memory also leads to system errors. Then we have the IRQ and FIQ exceptions also. IRQ and FIQ have independent routing controls and are often used to implement secure and non-secure interrupts. Then we have the virtual interrupts. The system that uses virtual interrupt has more complex needs for interrupt handling. Some interrupts may be handled by the hypervisor and some may be handled within the VM. So this is a syntax how to show that how virtual interrupts need to be used and how these exceptions are handled. When an exception occurs, then immediately the ARM it copies the CPSR into the SPSR, current program status register, into the status register. Sets then next to that, it sets the appropriate CPSR bits. Then change to ARM state, change to exception mode, and disable the interrupts. Store, then it return backs to the normal position. So this is assessment, and thank you for watching.